Audio Jungle.
I have amazing news for you guys. This is 1.4, Big Idea 9, and this is the last big idea for this section. So, very exciting. Final video. Hey, we're going to get to move on. Hallelujah. So, this is what we're going to be talking about. We're going to be talking about prime factorization. Two words you've seen before. At least you've seen prime. You know what it means to be prime. It means you can't be broken down any further. You don't have any numbers hiding inside of you. And notice that factorization starts with factor. So when I talk about a prime factorization, I'm talking about the prime numbers that another number is made of. Sound a little confusing. Well, the good news is we've actually done this before. You just didn't realize I was doing it. In some other videos, for example, we looked at 8. And I said to you, I asked you this question, what is 8 made of? Now, you didn't know it at the time, but I was sneaking in prime factorization before I even taught it to you. Because I said, well, 8 is the same as 2 times 4. And then I kept going with the 4. I said that 4 was made of 2's. It also was 2 times 2. And so what I learned then was I said, oh, look at that. 8 is made entirely of 2's. What I've just done here is what we call a prime factorization. I've taken a number, in this case 8, and I've broken it down to its prime factors. I've gotten it as small as I can get it without being broken any further. So this is what we're going to be looking at today. And it might just seem like an exercise in silliness. Why am I doing what I'm doing? But it's actually going to be very, very useful in the future. Okay? Plus, you can actually see a prime factorization problem on the GED. So let's take a look at some problems that I might encounter. So I could just be asked to find the prime factors of each number. Notice this doesn't say factorization, it just says factors. They're asking for a list. Okay? So what is the tool that we use to find prime factors? The tool that we use, you've already seen it, I just showed it to you, is called a factor tree. And there is a factor tree right there. Looks kind of actually more like, I always think it should be called factor roots because the numbers kind of spread out as they go down. But this little device here is called a factor tree. And basically, the way we'll use a factor tree is we're just going to make a little V coming out of the number here. And you can think of any multiplication fact for 36. That's the good news. You can start with any fact, whichever one comes to mind. So maybe I remember that 36 is the same as 6 times 6. You agree with me? 36 is 6 times 6. And I don't usually write the times sign in here, guys. You can if it makes you feel comfortable, but I'm a really lazy person. So, but that's what I'm saying here, that 6 times 6 is 36. Now, the rule of a factor tree is if you have a prime number, then you should stop. Obviously, we can't break a prime down any further. But if you have a composite number, you should keep going on that branch. So 6 is a composite number. It's composed of 2 times 3. So I bring that down. Now, 2 is a prime. I'm going to stop there. 3 is a prime. I'm going to stop there. Okay. Now, a lot of people will tell me, well, 6 is also the same as 1 times 6. And I say that's true, but you're not breaking the number down any further, so we're not going to use ones in a factor tree, okay, guys? That'll be the one multiplication fact we ignore, okay? But I do know that 6 is 2 times 3. Those are both primes, so I'm done. So what are the prime factors of each number? When I've been asked this way to just find factors, I'm looking for a list. So I'm just going to list out the factors I found. And truth be told, there's 4 of them here, but some of them are repeats, right? We really only have 2 and 3 as the factors, and that's exactly how you'll type in your answer in Quizlet. 2, comma, 3, no spaces necessary, okay? Okay, let's look at some other problems. Let's do 125. I purposely picked this number, guys, because although it's large, it's not hard. So you're probably thinking, Kate, I don't know any multiplication facts that involve 125. It's not on your basic multiplication facts that you have memorized. However, what we do see here is that it ends in 5. And you and I know that if a number ends in 5, it has a factor of 5. So I'm going to pull that factor of 5 out. Now, the trick is finding how many times 5 goes into 125. So again, you can use your calculator or you can use long division. I'm old-fashioned. I use long division. It's my friend. And I find that 5 goes into 25, or 5 goes into 125 25 times. So that's what I need on that other branch there. Okay? Now, 5 is a prime. I can stop there. But 25 is not. It contains additional 5s in it. In fact, 25 is equal to 5 times 5. See that? And so what have I learned here? I've learned that the only factor, the only number contained inside 125, the only prime factor anyway, is 5. So if I were going to list the prime factors, my answer would just be 5. No need to put 5, 5, 5, guys. That's redundant, okay? Okay. Next number I've got here is 29. So, taking a look at 29. Again, I don't know any multiplication facts about 29 off the top of my head. So I'm going to go ahead and look for factors using the same old tricks that I've always done. And just like on the last set, I'm only really need to go looking for 2s, 3s, 5s, 7s, and 11s. If I can't find any of those, at least in a smaller number, I'm not going to find anything at all. So, does 29 divide by 2? Nope, it's odd. Does it divide by 5? No, it doesn't end in 5 or 0. Similarly, we can't see 11s. So, we'll do a quick trick for 3s. 2 plus 9 is 11. 11 doesn't divide by 3, so neither will 29. And you're supposed to have your 7 times tables memorized. 7, 14, 21, 28, 35. I'm right past 29. I've got no factors to that. So a lot of people will tell me, well, then what's the answer? What are the prime factors? What I just realized is I realized 29 itself was a prime number. So therefore, the only prime factor is 29. Now that's new. Okay, so take note of this, guys. If a number is prime, its prime factor is itself. Make sense? Okay, let's do another one. Come on over here with me. We have the number 140. Again, I purposely chose a large number to show you how easy it can be to break some of these down. Notice, it ends in 0. It's got a 0 in its butt. Guys, it's got a 10 in it. And I don't even need to do long division to know when you divide by 10, you basically lose a 0. So what's the other side of that fact? 14. 10 times 14 is 140. Great. Neither one of these are prime, so I better keep going. 10 is the same as 2 times 5. Those are prime. I can stop. And 14 is the same as 2 times 7. Those are primes. I can stop. So what's my answer? What are my prime factors? Well, I see 2s. I see 5s. And I see 7s. Now, truth be told, guys, order doesn't matter. I could have written this 572 or 752 or 2, but the way Quizlet is designed, it'll only accept one answer. So please write them in numerical order. Let's go from smallest to largest when you enter it into the set so that it doesn't tell you you're wrong when you're not. Okay, that's how I designed them all. So you enter them in that way. Okay, that's my answer. I'm going to try 171. Now I'm trying to trick you. Let's try it again. Okay. Looking at 171, I don't see any obvious factors. Okay? Obvious, guys, being 2 and 5. In this case, 11 isn't obvious because it's a 3-digit number. So I've got to go checking for 3, 7, and 11. Trick for 3s is the sum of digits. Do Do a sum of digits, I get 9. Is there a 3 in there? Indeed there is. Look at that. And 3s are the most commonly hiding numbers. So don't miss them. Use your tricks. 3 goes into 17 5 times. Remainder 2, drop a digit. 3 goes into 21 7 times. Got 57. Now, a lot of people will stop looking for 3s at this point, but I warn you, just because I found one 3 doesn't mean I can't have another. We've seen other problems that have the same number more than once. So I'm going to check for 3s again. 5 plus 7 is 12. 12 divides by 3, so does 57. Let's go ahead and pull that 3 out. 3 goes into 5 once. Remainder 2, drop a digit. 3 goes into 27 9 times. So that means that 3 times 19 is equal to 57. There we go. Now, 3 is a prime, 3 is a prime, and I'll tell you right off the bat, I have my primes memorized a lot higher than y'all do. 19 is a prime as well, but if you cared to check, you could check it, and you would not be able to divide by 2, 3, 5, 7, or 11, which would quickly assure you that 19 was a prime. So, what are my primes? My prime factors for 171, 3, and 19. Okay, whoop, last one. We're almost done, almost done. Let's try 91. Okay, so once again, I don't know any facts. If I don't know it off the top of my head, I can just use my tricks. Doesn't divide by 2, doesn't divide by 5. 9 plus 1 is 10. There's no 3 in there. How about 7? I don't know. I got to check with long division. 7 goes into 9 once. Remainder 2. 7 goes into 21 3 times. That's perfect. No remainder. It divided. That means 91 is the same as 7 times 13. Now, guys, you're probably thinking, oh my gosh, she's making us do so much long division. But for those of you that were paying attention, there's 91 again. Same number I used last time. There's not a lot of these tricky numbers, but the same ones trick you guys over and over and over again. So this is one that often pops up. I wouldn't be the least bit surprised if he was on your test, because these are large, scary numbers that a lot of people don't know. 7 and 13. So awesome. 7's a prime. 13 is a prime. I can't go any further. The prime factors of 91 are 7 and 13. Box that up, send that out the door. That's your answer. Homework for this, I suggest you go ahead and pause this video, try 1.4p, listing prime factors, and then come join us for a pretty similar problem. Uses the same concepts, but the answers look a little bit different. Next kind of problem we're going to look at is very similar to the last one. They changed the wording just a little bit, and that's going to change the way we write our answer. So this question looks almost like the last one. If you remember, the last problems we did said find the prime factors, and we made a list. But this problem says find the prime factorization. Factorization. So we still see the word prime here. And the word prime is that big clue that the tool that we're going to use is the factor tree. A tree sees the primes. But it doesn't say prime factors, it says prime factorization. So even though we start the same way with the tree, we're going to write our answer a little differently. Let me show you. So again, you can start with any fact about 24, okay guys? It doesn't matter if you start with 2 times 12, or 4 times 6, or 8 times 3. We're all going to end up in the same place. I'll start with 8 times 3. 3 is a prime, 8 is not. I got to keep going. 2 is a prime, 4 is not. I got to keep going. And I've got 24 broken down into primes. Now, what is a prime factorization? A prime factorization in math speak is writing a number as a product of its prime factors. Now, what does product mean? We haven't learned this word yet. We're going to look at it a little more in the next video. But real quickly, product means multiplying. So when we're writing a number as a product of its prime factors, we're going to take the prime factors that we found and we're going to write times signs in between them. And again, I'm going to go from smallest to largest just so that you and I can agree on what our answer should look like. So 2 times 2 times 2 times 3. Now this is different from our last problem. When we were just listing prime factors, I told you not to repeat. With prime factorizations, you will repeat. Because what I need is this is the answer right here. This is counterintuitive for a lot of you guys. You feel like that can't be the answer, I have to do the timesing. No, actually what I'm asking you to do when you find a prime factorization is to pull a number apart to see what it's made of. And in fact, if we were to multiply this, do you know what we would get? Let's try and see. 2 times 2 is 4. 2 times 3 is 6. And if I multiply together 4 and 6, look what I get. 24. Right back to the beginning where I started. So that's kind of the point. What I'm saying is 24 is the same as all these numbers multiplying. So this is my answer. Now, let's talk Quizlet. You're going to go to type this answer into Quizlet. There was not a times sign for me to use when I typed in my answers. So what did I do? I used the X key on your keyboard. So you are going to need to type 2x, 2, just a lowercase x, 2x3. And we're going to use X for times anytime we need to talk about times from here on out. So just a warning to you, that's how you're going to type it in. And no spaces. And Quizlet should accept your answer, okay guys? So now let's try 42. Okay, so again, you can start with any facts that you know about 42. I happen to know that 42 is 6 times 7. 7's a prime, but 6 is not. And 6 is 2 times 3. Those are both primes. Again, I'm just going to write them in numeric order, smallest to largest. So I'll write 2 times 3 times 7. That's my answer. Easy, easy. Let's look at 81. 81. I know a fact about 81. It's 9 times 9. But 9 isn't a prime. It's made of 3's. And look what I see. I see that 81 is made of 4 3's. Now, the way we're going to write this in Quizlet is 3 times 3 times 3 times 3 when we do a prime factorization. But I need to warn you that this isn't the only way to write this problem. In fact, if you've been in any math class before, you may have also seen this written as this. 3 to the 4th power. If you're used to that way, that's awesome. We're not typing them that way yet. We will learn to later. If you've never seen that before and that looks like gibberish to you, don't worry. It's coming. Just gave you a little preview. Okay? So this is what we'll type into Quizlet. Okay, let's do 160. Again, I'd like you guys not to panic when there's a 0 on the butt. We know there's a 10 in there. The other number must be a 16, okay? 10 is made of 2 and 5. 16 is the same as 4 times 4, but 4's are made of 2's. Okay, that's a lot of 2's. So when we go to type this answer into Quizlet, we've got 2 times 2 times 2 times 2 times 2 times 5. Holy moly, I got long. But that is the answer. Once again, I'd like to point out to you guys, if you'd like to check your work, you can just multiply the numbers back together. 2 times 2 is 4. 4, 10. 4 times 4 is 16. And 16 times 10 is 160. Okay, awesome. Erase that. Let's try the last one. Let's do 95. Now, again, people freak out. Kate, I don't know any fact about 95s. No, but I bet you can tell there's a 5 in it. Well, how do I figure out the other number? Well, back to your friend long division. I've spent so much of my life attempting to convince people that I didn't invent long division. We collectively, math people, invented long division to make your life easier, but nobody believes me. So 5 goes into 9 once, remainder 4, drop a 5, 5 goes into 45 9 times. So 5 times 19 is 95. 5's a prime, and 19's a prime too, I promise. I wouldn't lie to you. But you can go ahead and look if you don't trust me. Check for 2's, 3's, 5's, 7's, and 11's. You won't find anything in there. So to write the prime factorization of 95, I just take these two numbers and slap a times sign between them. 5 times 19. That is my answer. Got some homework for you to practice, guys. 1.4.q will give you some practice with finding the prime factorization. Why don't you go ahead and give it a try. I wanted to leave you guys with one final warning. Very common that people, oh my gosh, I can't spell warning, guys. Apparently I have issues. There's an I in warning. Wanted to leave you with one final warning. People mix up the 3 problems because they're really similar when we're told to find factors. So let's look at the 3 types of problems one more time just to remember which tool to use. So the first type of problem, we can be told to find all the factors of 24 or find the factors of 24. We learned this last time. This was in the last video, but these commonly get mixed up. So what I want to remind you is when you've been told to find all the factors, or they just say the factors without specifying, the tool here is the factor rainbow. We find all the factors under the rainbow. So I'm going to do a factor rainbow for 24. Again, I'll remind you, starts with 1, ends with 24, and we do all the numbers in between. 2 times 12, 3 times 8, 4 times 6, and I'm done. So the factors for 24, what am I going to type into Quizlet? I'm going to type 1, comma, 2, comma, 3, comma, and so on this list here. No space is necessary. Got that? Okay, so how is that any different from these problems? Well, anytime you see the word prime in your problem, list the prime factors of 24. I'm not going to use a rainbow for prime. That word prime paired with factor gives me a clue that I need to use a tree. So I'm going to take a factor tree to 24. And again, with a factor tree, it doesn't matter what factor you start with. I'll start with 6 times 4. I get 2, 3, 2, and 2. When I type these answers in, where I'm just making a list of the prime factors, I don't need to repeat, and I put commas between the numbers. See that? Now, almost the exact same problem here. What is the prime factorization? But remember, when we had the ation on it, we write our answer a little differently. We still start with the tree, because we still have the word prime. But we're going to do our answer a little differently, if you remember. We write all the factors, including repeats, and we stick times signs in between. Or if you remember in Quizlet, that's the letter X. Those are the 3 types. Don't get them mixed up. Keep them straight, and you won't run into any issues. I've got homework for you, and I have great news. Here's the good news. This homework set, notice there's no letter after it. It's just 1.4, number theory, because we are finally done with section 1.4. This was a lot of information that I covered, and it's all actually called, it's under the subject of number theory. You don't need to have that memorized, but what you do need to do is go practice this set. Good news is there's no new information in here. None. All the problems you've seen before and all your old homework. Bad news is when they all get mixed up, we tend to get mixed up as well. So practice this long enough for the concepts to start staying still and for you to be able to remember which kind of problem needs which kind of answer, okay? Make sure you do learn mode for this after scatter. You can start with scatter if you want, but use your learn mode so that you can really get good at number theory.